Okay, here we are filming the answer key for this practice quest. Half a test or so, considering how long this unit has been. First question is, what is a vector? What's the vector? Vector, it is something with a magnitude and in a particular direction. So there are different systems, bearing and polar, but it's some scalar amount, a number in a particular direction. So let's practice that skill. This is polar. The convention here is that we rotate from our 0 degree angle. Positive is counterclockwise, or anti-clockwise as the British say. We go negative angle in the direction a clock hand would rotate. So for 9 to 10, we go 3, 6, 9 all the way out, and we rotate all the way around past 180 by 30 degrees to get to this point here, right on that line. 8 then is going out 1 unit less and rotating only 50 degrees. So here is 8, 50 in polar. Fill in the blank with a positive measure that will plot an equivalent point to this one up above. If we go negative 9, well, we start at the origin. If positive 9 is going this way before we rotate, negative 9 is going this way to right there. We still rotate in the positive direction, but a mere 30 degrees. So that's how you would answer that one. Convert B, convert 8, 50 into rectangular form. We use r, the radius, which is 8, and the cosine. C comes before S in the alphabet, just like X comes before Y. Keep those straight, don't mix them up. And when you do the math, to save time, it is 5.142 and 6.128. We can represent a vector not just with an angle and a direction. We can simply have it in X amount and Y amount. This is in the resolved component vectors, these are called, or unit vectors. If I'm going 5 units over and 3 units up to combine that to make this vector n, I can represent it like this. You can use parentheses, but these are little brackety things that represent vectors, so it's pretty clear whether you're dealing with polar angle notation or rectangular notation. So if we've got our 2 vectors here with their broken down into x and y components, we can add them very easily by just adding the x components and then adding the y components, and when I do that I get 1, 4. That's that vector. If I want to take 2 vector n's and subtract vector m from it, just think of these as the parentheses. I'm distributing the 2 in, I get 10, 6, and then a negative m vector is like adding the opposite. So the opposite of negative 4 is 4. The opposite of negative 1 is negative 1. I get 14, 5 for that resultant vector if I added those. Then sketch the following vectors and add them visually using the parallelogram method. Okay, so I thought I would show you how to do that. The first vector is 16 at an angle of 100. So again, rotating this way past 90 by 10 degrees. I'm going to call that 16. If that is 16, then that's about 8. So 9 is a little bit longer than that. So you have to kind of imagine a circle drawn with that as the radius. If I'm going in 200 degrees for my next one, I go past 180 by 20 degrees, and I'm going to draw that, like I said, a little bit longer than that length out there. And that would be 9. That would be 16. The parallelogram method is just pick any arrowhead and go parallel to the other vector. So these 2 lines are parallel. Then starting at this arrowhead, I'm going to go parallel to this line. This is the parallelogram method. What you don't do is draw some connecting arrowhead to arrowhead. That is the #1 mistake rookies can make. It is this middle direction that we're going. That is the resultant. I'm making it a little too big, but oh well. That is the resultant, the result of adding those, okay? So it's going to go through there. All right, well, let's do the math and find out exactly what that is. We resolve the polar into its parts, which I've done there. R cosine of 100, 16 cosine of 100, 16 times the sine of 100 degrees. 9 times the cosine of 200 gets me that. 9 times the sine of 200 gets me that. I add up the x components, there they are. Add up the y components, there it is. But now I have to get that back into polar. It doesn't hurt to double sort of check just to make sure you haven't done anything wrong. It looks like I could go about 11 this way. and then go up about 12 to get to that spot. That makes sense. To go back into polar, I square each component. Just drop off the negative, because when you square a negative, it becomes positive. I square each, I add them up, I square rooterize it, and I get my distance. So the strength of that length of that arrow is 16.940. Finding the angle, it's always the angle that we're going to find is what we call the reference angle alpha. It's going to be the angle made with wherever your arrow is dropped down or dropped up to the horizontal line. So just remember that. I do tan to the -1. Again, drop off any negatives. It's just the y number, the second number over the first number. I get 48 degrees. So if this is 48 degrees and change, then polar, I'm going to wrap around all except for that 180 minus alpha gives me my theta. So that's going to be about 131. So I would just write, I don't know, for my final answer, it's going to be 16.940 comma 131 and 0.545, I think. Okay, so that's that answer. On to the other side of this. We got two kids in a sled being towed by their mom. She's pulling on that rope. Here's my sled. Pulling on that rope with a strength of 100 newtons at 39 degrees. Again, this is just a word problem. Draw a picture so you can make sense of it. Don't make it harder than it is. If she's pulling at this angle with that strength, then there's a horizontal part that's our cosine of theta, and there's a vertical part that's our sine of theta. When I do that math, it turns out the horizontal part is 77.7 newtons. Well, she needs 78 newtons, so this is not quite, very close. Not quite enough force to move it. Okay? If the kids weigh 165 newtons and you're pulling on the rope and it makes them a little bit lighter, it's going to drop them down to just above 100 newtons when you do the subtraction. Okay? Pretty straightforward. Finally, this is the mother of all problems. These are toughy. You have a sailboat that is traveling from home at a bearing of 153 degrees. It sails for 200 miles and then turns and sails at a new bearing. It's not the amount of the angle that they're turning, it's based on that which way is north. So the bearing is 275 for 70 miles. How far is the boat from home? If it needs rescuing, at what bearing should a search plane fly in the direction to find them? Okay, so keep that in mind. It's not them getting back home, it's someone finding them, all right? So here's the picture. They sail. Here's the bearing of 153 from north. That's how bearing works. You always start at 0 degrees north like the compass, and we go clockwise generally. This is a system that's not made up by mathematicians, by navigators and boatsmen, airplane pilots, and they go clockwise from the compass bearing north, 0. This is 200, so we want to convert that to polar. The strength is going to be the same, but we get there by going all the way around. 270 degrees is 3 right angles plus this little 27 degrees I worked out. If it's 153 coming down, I subtract that from 180 and I find that. Draw a good diagram and just remember these guys are right angles and you should be able to figure that out. Then I am now right here, or the boat person is right there. And so there's a new north. That way is north. And if the new bearing is 275, that means they go all the way around 270 degrees plus a little 5-degree angle there. Okay? So what is that in polar? In polar, that's going almost all the way to 180 or 175. So that's where that comes in. So then I resolve it. I break it down. 200 times the cosine of 297, that gives me that. 200 times the sine of 297 gives me that. It makes sense that I go over about 90 and down about 190 something or 178. This one is going mostly in the negative direction with a little bit up, so I resolve that. When I add them, I get the rectangular sum of those two. But now I have to convert that back to the length, so again I square them. I didn't drop off the negative, but I could have. I just put parentheses around it. When I square it, it becomes positive. Just drop that off and you'll never be subtracting. You'll never subtract in there. I square them, I add them up, I square root them. It's always going to be a little bit longer than the longest number. There it is. 173 is my distance. When I do that tan to the minus 1 of my y value, 172 over my x value, 21. I'm going to drop off the decimals to save time. I'm going to get the angle 83 degrees. Well, maybe a little sidebar sketch. If I've gone down and over and I'm right here, the angle I'm making is this angle right there. So I need to add 90 degrees to that angle to come up with my bearing. So I just add 90 degrees and I will get a bearing of 173.022 degrees, and that distance home. So that's my final answer, and I'm sticking to it. Thanks a lot.